So here's a problem. You've got this really nice, highly detailed LIDAR scan of an area in the world. You're working with it in QGIS, but you've noticed that wherever there's water, there are these strange artifacts that make the surface of the water almost look like shattered glass or something like this. This is a problem because if you want to run any kind of analysis on this raster information, that analysis isn't going to be able to tell the difference between what is land and what is water. Because insofar as this DEM is concerned, everything is one big continuous surface. So in order to run analysis on this data, we first need to work out a way to subtract everything that is a body of water. I'm going to show you a very quick and relatively easy process by which we will clip and mask our data. So we'll create a copy that doesn't include the water. In order to do this, I first need a shape that accurately represents the land. That is any part of the data that I want to keep. Now, you may very well have this layer on hand, but in my case, I actually don't. I actually don't have a very accurate shapefile that represents the land with all of the detail of the docks and the islands and that sort of thing. But what I do have is a very accurate shapefile of the surface of the harbor. So what I need to do is actually just perform a simple inversion of this shapefile, and then I'll have an accurate shape representing the land. And this is what I'll use to perform the clip. If you already have this layer and you don't need to do this inversion, then you can skip ahead to the next step. Okay, so here I have a shapefile that represents Sydney Harbour. It represents the body of water that I actually want to remove from the dataset. The first thing I need to do is create a layer that I can perform a difference operation on in order to produce my accurate land mask. I will press Layer, Create Layer, New Temporary Scratch Layer. The geometry type is going to be polygon, and the CRS will be whatever the project is. So I will select Project CRS. Press OK. The next thing I will do is make sure that I've got the right settings in my project, because there's a small chance that if you do this, you will create invalid geometries. And depending on how your project is set up, this might cause the program to abort the operation. So before we go any further, I'm going to go to Settings, Options. I'm going to go to Processing, and then General. And then I'm going to make sure that where it says invalid features filtering, this is set to do not filter. Press OK. And then we can continue on. So the next stage is to create a rectangle, which will be what we perform our difference operation on. So I press this green blob up here, add polygon feature, make sure that I've got my rectangle from Extent tool, and I'm going to click once at the top left-hand corner, and then click once on the bottom right-hand corner, completely overlapping my target data. I'm going to press Save, and then I'm going to search in my processing toolbox for difference. So here underneath Vector Overlay, I'm going to double-click on difference. I'm going to choose New Scratch Layer as my input layer, and for my overlay layer, I'm going to choose the shapefile that represents the body of water. I'm going to press Run, press Close, and then I'm going to turn off the scratch layer, turn off the original shapefile, leaving just the difference. So this is now a high resolution shapefile that represents the coastline. And you can see it's kind of picked up all of the detail of these docks here, which is going to be great for me. So now that I've got my difference layer, I can use this to clip my raster data. So to do that, I'm going to search in my processing toolbox for clip raster by mask layer. Double click on that. Input layer will be my merged 1 meter Sydney Harbour raster. That's the raster that we're talking about. That's our target raster. And the mask layer will be the difference shapefile. And I'm going to leave everything else as it is, except for where it says assign a specified NoData value to output bands. And here I'm just going to type in 999,999. If I have this unspecified, then I might end up with the resulting pixels having a value of 0, which is fine for some types of analysis, but is not ideal for other types of analysis. So I'm just giving it an arbitrary number so that those pixels are assigned a NoData value. And with that, I'm going to press run. Press close, turn off the original, turn off the difference, and there we have it. There is our cleaned up LIDAR data. So to test if this still works, I can of course run a little bit of analysis on it. So for example, let's say I want to generate a hydro analysis of this. I could just go to my Wang and Liu, where I'm going to fill sinks on my clipped. That's right, that's all good. Press run. Then I'm going to find my filled DEM. And I'm going to run channel network and drainage basins. Press run. And there you can see that the hydro analysis now has its streams terminating at the shore, as they should do. Similarly, if I want to run contours, my contours are now looking much, much cleaner.